Welcome to the first lesson of Unit 5. So let's get started with what we know. We know that a dependent variable is located on the y-axis and the independent variable is located on the x-axis. The independent variable does not depend on another variable. It does not change by any other variable. The dependent variable, however, does. So as the independent variable changes, it will affect the dependent variable. So let's look at some examples and identify the dependent and independent variables below. Does the outdoor temperature affect the amount of fuel needed to heat a house? We're talking about outdoor temperature and the amount of fuel needed to heat a house. Which one do you think would affect the other? Does the amount of fuel needed to heat a house affect the temperature outside? Or is it the other way around? How hot or cold it is outside will affect how high you turn on your furnace. So your independent variable is your outdoor temperature. The weather outside we cannot control. Right now it's January, it's very cold. Most of us would probably prefer it to be a little bit warmer outside, but we can't control the weather. So the outdoor temperature is the independent variable. How high we turn on our furnace, how much fuel is needed to heat our house will depend on how cold it is outside. The colder it is outside, the more fuel there will be needed to heat our house. Number 2, is there a relationship between people's age and their heights? So the first thing I'm going to do is I'm going to identify the two variables in this question. So age and height. Now I'm going to think, does the age affect someone's height or does the height affect someone's age? Well, usually the older you are, the taller you get until you're an adult and then you stop growing. Okay, so someone who is a year old will be much shorter than someone who is 20 years old. Number 3, does the amount of rain in a region depend on its latitude? Okay, so the two variables here are the amount of rain and latitude. So the independent variable here is the latitude. Where exactly do you live on Earth? Different parts of the world receive more rain than other parts. That's why we have rainforests and deserts. Now, depending where you live will dictate how much rain you get. That'll be your dependent variable. The amount of rain depends on the latitude, where you live. Okay. So you should have been exposed to a scatter plot in your elementary mathematics years, but I'll remind you what a scatter plot is. A scatter plot is a graph that shows the relationship between two variables in which points are plotted on a coordinate grid. When the points form a pattern, there is a relationship between the variables. If there is no relationship, the points will be randomly scattered. So Julie gathers information about her age and height from the markings on the wall in her house. So she's put it here on a table of values. The table of values here is horizontal instead of the vertical table of values that we've seen, that we're used to seeing. So in the note box, I just wrote that the independent variable always comes first in the table of values. Okay, so the age here would be the independent value when we're comparing it to the height, but it also just comes first. It's the top row of this horizontal table of values. So identify the dependent and independent variables. Okay, well, we already talked about this. So your height depends on your age. Okay, so then your age would be your x-axis, and then your height in centimeters would be your y-axis. Okay, so you can see that the scatter plot is simply Julie taking her points on her table of values and plotting them on the grid. Okay, just like we've been doing in all along in this course. Now, instead of connecting them because they don't create a straight line, we're just going to leave them just as points. And it's asking if there's a relationship between the variables. Well, yes. So as Julie's age increases, her height is also increasing. So that's the relationship. As the x values increase, her y values increase. As her independent variable increases, her dependent variable increases. The points in a scatter plot often show a pattern or a trend. So the trend is the direction in which the points are moving towards. Okay, so the pattern or the trend here in Julie's height and age is that we're creating this positive slope. So when we're reading a scatter plot, this is a positive relationship, okay, or a positive trend. So the positive relationship, if the trend of the scatter plot is rising to the right, the two variables are said to have a positive relationship, just like right here. So the negative relationship would be if the points are moving downward. Okay. And no relationship if there doesn't seem to be a direction that the points are moving towards, then there is no relationship. Now there's something called a correlation, which indicates the strength of the relationship. So if we have a strong correlation, the points on the scatter plot appear to be almost like a straight line. So they're close together and they almost form something of a straight line. Now, a moderate correlation is that the points are moving towards the same direction and they're just a bit of a wider straight line. Okay, and then a weak correlation is that the points seem to still be moving in the same direction. Okay, so like my points right now, they do seem to be moving in a positive direction, but they don't seem to be displaying a noticeable trend. Okay, and no correlation means that our points are basically scattered and we can't determine if there's any sort of trend, if there's any sort of direction that the points are moving towards. If it's a positive or negative relationship, we can't tell. Okay, so let's try identifying the relationship and correlation with these below. So the first one, we know that this is going to be a negative relationship because our points are moving downward. So this would be negative. Now the correlation, is it strong, moderate? Sometimes it's pretty difficult for us to determine if it's like between moderate and weak or strong and moderate. So here I'm going to say that this is moderate. Okay, it's not, these points don't really seem to be creating a straight line, but there is a noticeable trend. Okay, the next one, I would say that this is also moderate, and instead of negative, our points are moving upward. So this would be a positive, moderate. Next, this is a pretty strong relationship. Besides these two right here, this does seem to be forming pretty much a straight line. So I'm going to say this is positive, strong. D. I don't see a relationship here. I'm not sure if the points are moving this way or if they're moving this way. So I'm going to say there's no relationship. Okay. And there's no correlation. Okay, next, there is definitely a negative relationship here. But I'm going to go ahead and I'm going to say this is a weak relationship. Okay, and the next one, I don't know if the points are moving this way or this way. I'm going to say no relationship, no correlation. Okay, next, this is a pretty strong negative relationship. Next one, this one's an interesting one. So this is definitely a strong correlation because these points pretty much create that straight line, but they're not moving in an upward direction or a downward direction. So there isn't really a relationship. As x increases, our y values are staying exactly the same. So there really isn't a relationship between the x and the y variables. The x variable doesn't seem to have an effect on the y variable. So I'm going to say that there's no relationship, but there is a strong correlation. Next, this is definitely a strong positive. Positive, strong, strong, positive, same thing. Relationship. Okay, next, I don't see a relationship. And I don't see a correlation. Same with this one. And same with this one. Okay, last page. To be able to analyze and make predictions about data on a scatter plot, we need to use a line of best fit, or LOBF. So draw your line of best fit. is you must use a ruler. It has to be a straight line. Our line of best fit must follow in the same direction as our points. Okay, so I'm not going to draw a line of best fit in this direction. It has to be following the direction of the points. The line should go through as many points as possible. Okay, but if we don't have a perfectly straight line of points, then obviously you're not going to go through all the points, but you're going to try to go through as many points as possible. And then the points that you don't go through, okay, you want to make sure that you have the same number of points on the left and right side of the line. So for example, I can't obviously go through all of these points. So if I decide to draw my line here, or let me move up a little bit. Here, I would say that this is not an appropriate line of best fit. Even though you went through 1, 2, 3, 4 points, that's a lot of points. You have 3 points all on your right side that you didn't go through. Okay, so you want to make sure that your line has the same number of points that you didn't draw a line through on both sides. And another point is that you don't actually have to go through the origin. Okay, so my line, if it goes through the origin, doesn't appropriately reflect my direction and relationship of my points. So your line does not have to go through the origin. So my line, I'm going to try to maybe go through the first and the last point, and I would have almost an even amount of points on either side of the line. So I'm going to start with my first point. My first point is given to me at age 1, and I'm going to end at my last point, which is given to me at age 7. Okay, so I went through 2 points, and then I have these 2 points on my left, and then I have 3 points on my right. Okay. Okay, so making predictions, we use 2 different types of methods, interpolation and extrapolation. So to interpolate means you're making an estimation within the range of known data. So the data given to us begins at age 1 and ends at age 7. Okay, so if I ask you about information between age 1 and 7, I am predicting using interpolation because I'm given information between age 1 and 7. So I can use my line of best fit, which represents the information that has been gathered. Extrapolation is any information outside of the information that we're given. So making any predictions outside of the information provided. So any information that is before age 1 or that is after age 7, we would make predictions using extrapolation. So what we would do is to make predictions using extrapolation, we would just extend our line of best fit. So I'm going to extend using dotted lines. So you understand that I've extended our line of best fit. Okay, so our line of best fit begins at our first point of information and ends at our last point of information. Okay, and any predictions made within that information, we use interpolation. Actually, let me use a different color. And any predictions outside of our provided information, we use extrapolation. Let's practice making predictions using interpolation and extrapolation. How tall was Julie when she was 5? So again, we're making predictions using our line of best fit. So at age 5, which is right here, I'm going to follow the grid line to where my line of best fit is. And then I'm going to read across to what the y value would be at that point. So my line of best fit says it's approximately 112 centimeters. Okay, so because I made a prediction within my line of best fit, I used interpolation. Okay, and I know that we have a point for when Julie was actually 5 years old, but interpolation, we use the line of best fit. Okay, so we're just practicing using our line of best fit to estimate. How tall will Julie be when she's 9? Okay, so 9 is outside of our line of best fit. So I'm going to use extrapolation for this, but I'm using the same method. I'm following the grid line all the way to my line of best fit, which is extended using a dotted line, and then I'm going to read across to my y value, which would be 155 centimeters. Okay, so depending on your line of best fit, you could get different values, but they should be close. I mean, for the first one, if you got like 107 centimeters or 110 centimeters, that would be fine. For the second one, if you got like 152, 150 centimeters, that would be fine. It's as long as you're close, then it's just an estimation, so it won't be incorrect. C, how old was Julie at 100 centimeters? Okay. So 100 centimeters is here. So how old was she? So she was about 4 years old. How tall was Julie when she was born? Well, when you're born, you're 0 years old. So she was about 58 centimeters.